All right, the biggest thing that we need to learn today in this this section is that if a plus bi is a root, you automatically have to have its conjugate a minus bi, no matter what, always and forever. You with me? No matter what. So I'm going to pass out today's worksheet for you, and I'm going to do those as homework problems. So the front page says, find a polynomial function with real coefficients that has the given zeros. So I am telling you that if we're looking at problem number 2, that 4, 3i, and negative 3i are going to be the roots of this polynomial. You with me? Now, if that's a true statement, the very first thing I want you to do is look for any imaginary roots. Do I have imaginary roots up there? Now, look at the first imaginary root. What is that? 3i. Does 3i have its conjugate up there?
Yeah.
Yes. That's negative 3i, which is the last root, which means all of my imaginary numbers that I have as roots has the conjugate as a root as well, and it's already in the list. Do we all get that? If it is not in the list, you have to add it to your list. Do we understand what I just said? So the first thing we're going to do is we're going to set x equal to every one of these. X is equal to 4, and x is equal to 3i, and x is equal to negative 3i. Yes? Now, x minus 4 is equal to 0, and then these two I can write as x is equal to plus or minus 3i. Do you remember that? Remember we did that before?
Mm-hmm.
And how did we get rid of the plus or minus? We squared both sides. So x squared is equal to 9i squared. And what is 9i squared? Negative 9. So bring that over on the other side. X squared plus 9 is equal to 0. Then you can go ahead and multiply those together. X minus 4 times x squared plus 9 is equal to 0. So now you're going to FOIL those together. So that's x cubed plus 9x minus 4x squared minus 36 is equal to 0. I'm going to put this from highest degree to lowest degree. X cubed minus 4x squared plus 9x minus 36. This is an example of a polynomial with those given roots. Do we understand that? We good? Number 4. What do I do first? I'm sorry? Look for your imaginary roots. Do I have the conjugate of them there? I absolutely do, so I know I'm done. I don't need to add any more additional roots. So I'm going to go ahead and say that x is equal to negative 1, and x is equal to 6 plus 5i, and x is equal to 6 minus 5i. Bring this over, so x plus 1 is equal to 0. Bring over the 6, x minus 1 is equal to 5i. X minus 6 is equal to negative 5i. Do we see that? We good? Make this x minus 6 is equal to plus or minus 5i. How do I get rid of the plus or minus? Square both sides. So that's x minus 6 times x minus 6 is equal to 25i squared. Yes? X squared minus 6x minus 6x plus 36 is now equal to what number? Negative 25 is correct. Why? Because I squared is equal to negative 1. Go ahead and combine like terms. So x squared minus 6x and minus 6x gives you a minus 12x. 36, I'm going to go ahead and add 25 to both sides. So 36 and 25 gives you 61 is equal to 0. Now what am I going to do? Nope. I'm going to multiply these two together to give me an x plus 1 times an x squared minus 12x plus 61. Yes? Make sense? So that is x cubed minus 12x squared plus 61x plus x squared minus 12x plus 61. X cubed minus 11x squared. 61 take away 12 is going to be 49x plus 61. There should be a square in here, sorry. Dropping my power. Do we all understand that? Did everybody see that I forgot to put the squared on the x, the 11? I moved on too fast, sorry. Do we understand that problem, yes or no? May I move on? Okay, next. Number 6. I need the conjugate. Now, look on how it's written on your paper. Do you see that this square root of 2 is first in front of that I? And how I wrote it on mine, how it's different? Okay, I wanted you to be exposed to both ways that you can write it. We always feel comfortable putting the I in front of the square root because it makes us know that it's outside of the square root. So on your paper, I would go ahead and write it the way it's written on my board. It just makes more sense to you. Now, 0 is a repeated root. 4, and then I have 1 plus I squared root of 2. Am I done? Why? I need the conjugate. What is the conjugate of 1 plus I squared root of 2? Yep. Do we all understand that? Now, if I have x equaling 0 as a double root, how can I write that? X equals 0 twice, so isn't that just x squared equals 0? Right? So I have x squared is equal to 0, x minus 4 is equal to 0, and then x minus 1 is equal to plus or minus I square root of 2. Did you see how I kind of brought everything over that I took? That was a real number. That was a rational number. Does everybody see that? You good? Okay. Now, I'm going to go ahead and multiply those together. X squared times x minus 4 to give me an x cubed minus a 4x squared. Is that legal? Sure is. How do I get rid of the plus or minus? Square it. So if I square both sides, I'm going to have an x minus 1 times an x minus 1 is equal to, what is plus or minus I square root of 2 squared? I squared times 2 is correct. Now what is I squared times 2? Yep. That gives me a negative 2. So if I FOIL this, x squared minus x plus 1 is equal to negative 2. I combine like terms. By adding the 2, I'm going to get a 3 is equal to 0. Now what am I going to do with the red and the blue? I'm going to multiply them. So I'm going to have x cubed minus 4x squared times an x squared minus a 2x plus a 3. X to the 5th minus 2x to the 4th plus 3x cubed, bless you, minus 4x to the 4th plus an 8x cubed minus a 12x squared. So I have x to the 5th. -2 and -4 give me -6x to the 4th. 3x cubed and 8x cubed give me an 11x cubed minus a 12x squared. Do we understand that problem? Turn it over. Number 9. Number 9. You ready? Okay, the directions say use the given 0 to find all the zeros of the function. Now, I'm telling you that 5 plus 2i is a root. So what else has to be a root? Yep. It's not on there, but you know that it has to be. How many roots does this thing have to have? Has to have 3. So root 1 is this, root 2 is this, and we need to find root 3. How do we find root 3? We need to do synthetic division. So I'm going to do synthetic division at an imaginary number. Totally okay. Totally doable. It's a root, so therefore the remainder should be what? 0. So I have a 1x cubed minus a 7, leave some space, minus a 1, and then an 87. Why am I telling you to leave some space? Because you have to be certain that you are going ahead and putting in the imaginary part as well as the real part. I'm going to drop down the 1. 1 times 5 is 5. 1 times 2i is 2i. Do you see that? Yes or no? -7 plus 5 is -2 plus 2i. Now, pull up your graphing calculator. I'm going to go home and I'm going to get a new document. I want a calculator page. And you're going to put parenthesis 5 plus 2. Go to the left of the H key and hit the pi key. Go to the left of the H key and hit the pi key. And you want your I key. Arrow out to the right to get out of that parenthesis. Times parenthesis. Now, what did we say that was? -2 plus 2i, I think. And hit enter. What does that give you? Isn't that sweet? Doesn't that make your life so much easier? I'm not going to tell you that before you do your complex numbers worksheet. I'm going to make you do your complex numbers worksheet by hand, right? Do we understand that? But you should be having a huge aha moment. Should you miss any complex numbers on the test? No. Okay, so you're going to have -14 plus 6i. Now I'm going to go ahead and add the -1 to it to give me -15 plus 6i, but watch. I'm simply going to take this and subtract 1 to get that -15 plus 6i. I'm doing less keystrokes. Then I'm going to go ahead and take that and say times, parenthesis, 5 plus 2, I is in the pi, and hit enter. And it's going to bust out the -87, which is what I want it to be. Do we see that? So this is a -87, which gives you 0 as your remainder. Is that what I wanted it to be? Okay, now what? Do it again at 5 minus 2i, correct? The remainder again should be 0. I'm going to drop down a 1. 1 times 5 is 5. 1 times -2i is -2i. -2 plus 5 is 3. The 2i's cancel out. 3 times 5 is 15. 3 times -2i is -6i. 15 and the 6i cancel out to give you 0. What degree am I at now? This was degree 2 up here, and now this is degree 1 here, which means x plus 3 is equal to 0, meaning x equals -3 is my final root. Do we all understand that, yes or no? You have the rest of the period to work on any and all homework that you have. I will put my answer keys up to 2.5 worksheet 1 and 2.5 worksheet 2 up here, as well as the 2.5 worksheet 3. You have the rest of the period to work. We are out of here at what? 7:02. You guys, not much, but you have a little bit of time. Okay? As always, great job, guys.